All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 81's on the screen. Get started, please. That shouldn't be a problem by now. 5 minutes. Copy and go. All right, good participation. Number one. What'd you get for number one, Joel? Approximately 5.4. Hands, have you got that? All right, looks about right. Number two, I'm going to go over number two really quick just for the sake of time. So if we plot without a table, our parabola, or our y equals x squared, goes through the point of origin, and it looks like this. However, we need to write our general rule. If I substitute these values, our general rule should have been g of x equals negative parentheses x plus 3 squared minus 5. Tell your neighbor the new vertex where we're going to land at the end once we do the transformations. New vertex. Joel, pass someone. That is correct. At negative 3, negative 5, negative 3 of x, negative 5, so it's somewhere down here. However, before we move that parabola down there, look up, guys. Tell your neighbor what this does to the entire function, please. What does that do? Yeah, it flips it. So it should be upside down like so. All right. Number three, factors for number three. Tell your neighbor before Jalen passes someone. Factors for number 3A. 3A. Pass someone. Jalen. Diego. Rosas. Go. 5 parentheses, parentheses. All right. So the GCF was 5. We're left with x squared minus 3x plus 2. And then from there, you factor that. So what'd you get for those factors right there? Jose, what'd you get? And x minus 1. That is correct. All right. I'm going to do number 3B, once again, for the sake of time. So we got 6 times 2, that's 12, and 7 down here. So what two numbers multiply, give me 12 when you add them, give us 7. Ivan. Factors of 12 that add up to 7. 4 and 3. Hands, have you got that so far? All right. So I'm going to use a shortcut just so that for the sake of time, my leading coefficient is 6. So I make a fraction here and a fraction here. So my first fraction is 6 over 4. Can I simplify this? Yes? What is a simplified fraction? 3 over 2. So my factor is 3x plus 2. All right, let's look at the other fraction. The other fraction is 6 over 3. Can I simplify that one? Yes, which is what? 2 over 1. So my factor is 2x plus 1. And there, those are my factors. Once again, this method is called the Escalante method. You've probably seen the movie, yes? Stand and deliver, yeah? Good. Let's go to number 4. Number 4. Who went last? Diego? Oh, but he didn't answer. Okay, then I pick someone. Help me with this one, please. Diego, Romo. What do I write? -2. Let's go. Tell your neighbor why we wrote 0 right there, please. Yeah, because we're missing the third degree, so therefore that coefficient has to be 0. Okay. So bring down the 3. -2 times 3 is -6. Combine. -2 times -6 is 12. Combine. -2 times 14, that's -28. Combine. And -2 times -35, that's 70. Combine. That's 74, our remainder. So, if we start off with a 3x to the 4th, what do we have here now? Pass them one, Diego. Boop. 1. Let's go. That is correct. Hands, if you got something like that. All right, so make sure you're practicing this, guys, because we're about to get into a session. It's coming up, I think, the following week, where we're going to need this process to go a little bit faster, and it's going to be repeated a lot. So make sure you got this process down. All right, and last but not least, graph. All right, before I do that on the coordinate plane, look up to the screen. Look at this one. This is y equals -4. Tell your neighbor if that line is going up or down or side to side. Up or down, side to side. Everyone, it's going what? Side to side. That is correct. It's going through -4, which means -4y is right there. This is my point of origin, 0, 0. Okay? With that same idea, tell your neighbor what this line looks like, side to side or up and down. Everyone? Up and down through -2, that is correct. And we're going to be using that in today's session. Hopefully we got plenty of practice. All right, copy the agenda, please. Warm-up number 81, parabolas. Your home plate for tonight is page 183, numbers 1 through 4, and 5 and 6, which I will post right now on the screen as soon as you copy the agenda. All right. Last night's home plate was 4 of these. So make sure you get that out and turn that in to me today over here by hand. Make sure it has your name, date, period on them, please. You need to staple them. Staplers are over there by the books over there in the corner. And take a picture of the screen. Look at that one on the screen over there, numbers 5 and 6. Take a picture of that. And page 183 is in Canvas under the quadratic equation module. All right, here we go. Our objective for today, I can write and graph a quadratic equation of a parabola. I can write and graph a quadratic equation of a parabola. So we don't need a fair model because we did the fair model yesterday for parabola. By now we should know the definition, yes? All right, turn to your neighbor to know the definition of a parabola, please. Definition for a parabola. All right, definition, parabola. Jaden. One key word. Give us a key word to get started. Help them out, everyone. Equidistant points. From where? What two things? From what and what? Alessandra. Equidistant points from what? The focus and the directrix. That is correct. That's why we don't need a Frere model. We saw that yesterday, and it looks like this. I actually animated the parabola forming like so, and we came up with non-examples and examples. All right, and of course after that we derived it. This was the home plate. You know this by memory. So tomorrow if you walk in and if I give you a blank sheet of paper, you should be able to produce that, and that. All right. So, because tomorrow is Friday, just FYI. All right. And of course, we come up with a standard form equation, but today we're looking at two different types. So write your utensils down, look up to the screen. The first type is known as a vertical parabola. That's the one we found out yesterday, and it looks like this. Is that correct? And different ways of writing it is like this and like this. Don't worry about those. I'm just giving you the way they look, but we're only going to focus on the top one. A vertical parabola is known as a vertical parabola because it opens upward or downward, reflecting off the directrix. Now, here it goes. Hopefully those of you that did the practice last night, you remember. Here it goes. It can open upward or downward like so. All right. Now, question. Look at this line of the directrix. Look at it. Is that an x equals a number or a y equals a number? Tell your neighbor. What is that? The directrix. X equals or y equals? All right. Alyssa, go. That is correct. It's not an x, it's a y, because a y goes what? From side to side. We saw that on the warm-up. Is that correct? Yes? Yes, I said you. All right. So, does everybody agree that this is a vertical parabola? Yes. And when it starts how? X squared equals 4py. Today we're also going to look at what we call a horizontal parabola. So if vertical parabolas start with x squared, what do you think horizontal parabolas start with? Everyone? I'm going to repeat that again. Maybe you didn't hear me. If vertical parabolas start with x squared, horizontal parabolas start with, yeah, that is correct, y squared. And basically we just switched the variables, and it's the same way written for both. However, it's known as horizontal because instead of opening up and down, it opens which direction? Side to side. That is correct. Reflected off the directrix. It can open to the right or to the left. Now check this out. Look at this line. Look at this directrix line. Is this an x value or a y value? Yeah, it's an x equals. So, with blue and red, copy this, please. Vertical parabola and horizontal parabola. I'll give you some time for that. Copy and go. Ready to go? Ivan, you good? All right, Ivan's good. All right, so let's move on. Once again, vertical parabola opens up or down. The directrix is y in a number. Horizontal parabola opens from side to side, and the directrix is x and a number. Now, before I give you a practice problem, look up to the screen. Look up to the screen. Here it goes. They're going to give us a focus, and they're going to give us a directrix. So, and they're going to ask you to write an equation. Now, you need to know the two equations for right now. The first one is what? X squared equals 4py. What is the second one? Y squared equals 4px. Those are the only two options. Okay? So with that said, your question might be right now in your noodle, Mr. Q, but how do I know which one is which? Good question. Let me show you. Whenever they give you these two pieces of information, the first place you're going to go to is to look at the directrix. So check this out. If the directrix starts with y equals to a number, let's say 7, what does this line look like? It looks like this, is that correct? Which means the parabola is going to open either up or down. So that means that's a vertical parabola. That means you're going to write what? X squared equals 4py. However, if they say directrix is x equals negative 9, what kind of line is that? That opens which way? Up and down. So that means my parabola is going to go from side to side. So what equation do we use? Y squared equals 4px. Is everybody following? All right, let me give you some practice ones. Don't copy this. Just look at it. So you're going to discuss it with your neighbor. Here it goes. What if I gave you y equals negative 100? Tell your neighbor what equation you would write to get started. All right. Diego Rosas. Help him out, Jose. Joel? That is correct. X squared equals 4py. All right. And from the quarter, Joel, let's go. All right, let me give you another one. If I gave you x equals 1, tell your neighbor what equation you would write. What equation would you write? All right. Diego Rosas. That is correct. Hands if you got that. All right, so far so good. What if I said x equals negative 10? Tell your neighbor what equation would you write? Yeah, the same one. Same equation. Doesn't matter if it's positive or negative. How about if it's y equals 1 million? Tell your neighbor which equation to write for that one. Yeah, x squared equals 4py. That is correct. All right, now that we got that, copy example number 1, please. It says, write and graph the equation of the parabola passing through the point of origin, focus 0, 2, directrix y equals negative 2. And I want you to make a coordinate plane that looks like this, from negative 6 to 6 on the x, negative 6 to 6 on the y. I'll give you some time. Copy the instructions and everything for this problem at least so you can have one example complete. Copy that. I'll give you some time. Go. All right, you should be almost done setting up, if not completely done. Now, just a reminder, what was the word for the year, for the school year that I told you to remember? Graphing. My goodness. It's going to be graphing all the way through. There will be algebra stuff that we're going to do, but mostly is what? Graphing. That's why you need your graphing notebook, people, so you can set up your coordinate plane a lot faster. All right, here we go. Writing utensils down, look up to the screen. I'm going to go through the process so you can have the process down, but I'm going to go one step at a time, okay? But stay focused because this is where some of you get lost a tiny bit. So here it goes. This problem says, write and graph an equation. So I'm going to start with write an equation. Notice they don't give us anything in regards to an equation. The only thing they give us is a focus and the directrix. All right, so what is the first thing I do? I look at the directrix. By looking at the directrix, tell your neighbor what equation we would write if I'm looking at the directrix. Diego Rosas. X squared equals 4py. Write that down, please. That is correct. So notice the process. If they say write, the first thing you look for is what? The directrix, and that's going to tell you which equation to write. All right, so far so good. But now we need to customize it to this information that they give us. So I'm going to rewrite this as x squared equals to 4 parentheses y. So which means I need to substitute a value for the variable p. Notice that I did it in red. What did we use in red for the graph? Everyone? Last night for your home plate, what did you use in red? The focus. So underline the focus in red, which means I'm going to take that value and substitute here the 2 for p. Now I can rewrite it. This is x squared equals 8y, and I'm done with writing my equation. From 1 to 5, I'll come to right there. Yeah, 5, 5, 5. Okay, we got this. Now let's start our graphing process. What did we do last night for the home plate to get started? Well, we plotted our focus, 0, 2. We do that in red. There it is. What else did you do? Oh, I did the line, Mr. Q, which is known as the directrix, going through y equals negative 2. Y equals negative 2 is down here. There it is. That's my directrix. What did you do right after on the home plate? Oh, you plotted the midpoint. Do you guys see the midpoint between these two? Yeah, it's the point of the origins right there. They even tell you here on the problem, point of origin. There it is. Now, before we graph our parabola, can you picture it? Look up to the screen. Can you picture it going through here? But we need more precise points. How do we get that? By making a table. X and y. And once again, what's our bread and butter for our x values that we use, everyone? Negative 2, negative 1, 0, 1, and 2. All right, so I'm going to take my equation, and instead of x, I'm going to put a parentheses squared equals 8y. And I'm going to use green to come up with my values, because that's what I'm going to use to create my parabola. Remember yesterday we used green for our parabola? So I'm going to use negative 2, my first value. So what is negative 2 squared? 4 equals 8y. And now I just need to solve for y, which I need to divide by 8, both sides. So that gives me y equals 4/8, which is what? 1/2. That goes right here. Now check this out. What I like about this activity is that that same value goes with positive 2. Why? Because it's a parabola. It's reflecting on one side and the other side. Okay? Well, let's do it again. Parentheses squared equals 8y. And now we're going to substitute what? Negative 1 of x. What is negative 1 squared? 1 equals to 8y divided by 8. So 1/8 equals y. Goes right there and also goes for the positive 1. So far so good? And of course 0 is always 0. Let's plot those points. Negative 2 of x, 1/2 of y, which is right there. Negative 1 of x, 1/8 of y, which is close to the x-axis. 0, 0, and then we reflect the other 2 points to the other side. And there's our beautiful parabola. Woo-wee! Let's go! All right. How we doing? Good? From 1 to 5, how comfortable with this process? All right. Let's do another one. This was example what? 1. Okay, let's go to example 1 super Q. Give me a second. Example super cute. Don't copy the instructions, just copy the focus, the directrix, create a little coordinate plane on the side. And I'll give you some time. I'll give you a head start to see how you do by yourself. Copy and go. All right. So let's see. It says, write and graph the equation of the parabola passing through the point of origin with focus 0, 3, and directrix y equals 3. So, first thing we do is write an equation. Where do we look first to? We look at the directrix. So with that said, what equation did you start with? Please, Diego Rosas. X squared equals 4py. Hands if you got that. All right, and then you rewrote that. X squared equals 4 parentheses y, because we need to substitute a value for p. Tell you ever what values you substituted for p, so like that Diego can pass it to someone? Diego, pass someone. -3, because that's our focus. Hands, have you got that? All right, so we get x squared equals -12y. Hands, have you got that for your equation? All right, so we're done with our equation. Let's start graphing. Our focus is 0 of x at, Our focus is 0 of x and -3 of y, which is down here. Our directrix in blue goes through y equals 3, which is right there. And can everybody see the midpoint between these two? It's at where? At 0, 0. So you know which direction you're going to open up that parabola, please? Yeah, it's going downward, yes? Okay, but we need a table. -2, -1, 0, 1, 2. All right, give me these values, please. Who went last? Jalen, pass someone. -2. Okay, help them out. Diego Romo. -1/3, and that goes for -2 and 2. How about for -1? -1/12. That's for -1 and 1. And of course 0, 0. Let's plot those points. Here we go. -2 of x, -1/3 of y, which is about right there. -1 of x, -1/12, very close to the x-axis. 0, 0. These 2 points reflect on this side, right there and right there. Hands if you got something like that by yourself. Yeah, let's go, let's go. From 1 to 5, how comfortable are you with it so far? 5 4s, 5 4s, couple 3s, okay. All right, copy this next one, please. Example number 2. Oh, there it is. Copy that one, make a new coordinate plane. And it reads again, write and graph the equation of the parabola passing through the point of origin with focus 5, 0. Directrix, x equals -5. I'll give you some time to set it up. We'll do this one together because it has a little twist to it. Once again, you didn't need to copy the instructions. You already have them. You copied the focus 5, 0. Directrix, x equals -5. So what is the first thing they want us to do? They want us to write the equation. We look at the directrix. And tell your neighbor what equation you wrote, or did you start to write? All right, help us out. Caleb, what equation? Hands if you got that. Y squared equals 4px. That is correct. We rewrite it. Y squared equals 4 parentheses x. Tell your neighbor what to substitute in there for p, please. Pass someone, Caleb. Who? Jaden. Times 5. That is correct. So my new improved equation is y squared equals 20x. Hands if you got that? All right. Plot what we have. Let's start with the focus. 5, 0 over here. That's our focus. Our directrix is x equals -5. There it is. And can you picture the midpoint between the two? Yes, right there. And they say it here again that it's going through the point of origin. All right. Get a table going. X, Y. Now, before you write that values in, look up to the screen. Look up to the screen, please. Let me go back to the previous two. Look at this one. We had an x squared, so we got values for x at -2, -1, 0, 1, and 2. This one as well, we had an x squared, so we got x values of -2, -1, 0, 1, and 2. But now this one is at what? Y squared, which means I need to fill in values to get started at the y value. So you write -2 right there, -1, 0, 1, and 2. Now before I move on and substitute values, tell your neighbor what we did different on this one than the previous ones, please, so they can understand. What did we do different from the previous one to this one? What did we do different? All right, what do we do different? Lorena, what did we do different from the previous ones to this one? Yeah, so we put values to the y instead of the x, so now we can substitute in here for the y. So here we go. My first y value is -2. So what is the -2 squared? That's 4 equals 20x. Divide by 20. So this is x equals to 1/5, and it goes here, and it goes here. All right, let's do it again. My next value is -1 of y. -1 times -1 is 1. Divide by 20. By 20. So we're left with 1/20 equals x. 1/20 there. 1/20 there. And this is 0, 0. All right, plot that. 1/5 of x is about right there. Everybody see where I'm at? Right close to the point of origin. And then we go to -2 of y, which is down here. There it is. Next, 1/20 is very close to the point of origin of x, and -1 of y. 0, 0. And then we reflect these 2 points over here. and we graph our parabola. All right, from 1 to 5, how comfortable are you with these? Let's see, 5 fours, okay. Let's do one more. Last one, here we go. You should be able to do this one completely by yourself. Here it goes. Example 2 super cube. The focus is 1/2 0, and directrix x equals -1/2. Copy and go. I'll give you some time. All right, check with your neighbor, see what equation they wrote down to get started, please, so I can call on Steve and get us started. What equation did you start with? See if they're following along. All right, Steve, go. For px. Hands, have you got that? Yes? All right, so far so good. And we're going to substitute a value in there for p. And let me pass it to Ivan, but tell your neighbor, what value are we substituting for p in there? What value? All right, what did you substitute in there, Ivan? 1/2. That is correct, because that's part of the focus. Therefore, we get y squared equals 4 times 1/2. That is 2x. Hands, have you got that? All right, so let's plot what we've got. Our focus is at 1/2 of 0, right there. 1/2 0. The directrix is at -1/2, which is over here. The point between, or the midpoint between those two is that point of origin right there. And we get our table. And since we have y squared, we start with the y at -2, -1, 0, 1, 2. Tell your neighbor what you got for your x values, so we can call on Frida to get us started on the x values for that. All right, Frida, what'd you get? 2, 1/2. Looks about right. So let's see. 2, -2. 1/2, -1. 0, 0. 1/2, 1, and 2, 2. Hands, if you got something like that. Let's go, let's go. That's going to be your home plate, guys. Make sure you do those 6 problems for home plate. Numbers 1 through 4 on page 183. It's in Canvas under the quadratic equation module. And the other 2 are on the screen. Have a good one. See you guys tomorrow. Bye.